Hello everyone. In this video we're going to be evaluating a function at two different points. We are given f of the quantity ax minus b divided by bx minus a, and that equals x squared minus 3x plus 1, and we're going to evaluate or find f of 1 plus f of negative 1. Now, I'm going to be presenting two methods, and the first method is just going to be a little bit more painful. Just to introduce the idea, I mean, sometimes one of the methods could look like an overkill, but the idea is to present different approaches. So let's start with the first method. And here, of course, we do need some conditions like bx minus a should not be equal to 0, so on and so forth. So certain things need to be satisfied for a and b in order for this function to be well defined. My first method involves substitution. And I want to get f of x, f of something. So I'm going to set this whole thing, that rational expression, I'm going to set it equal to z. I use a different variable. You can use a y as well, but f of x equals y is sometimes a standard way of writing it. That's why I'm avoiding y here. That's y. All right, let's go ahead and cross multiply here. We get ax minus b equals bxz minus az. Here, my goal is to solve for x and be able to write x in terms of z so that I can substitute that on both sides. Obviously, on the left-hand side, if you substitute something for x, whatever you find from here, it's going to give us z inside the parentheses. No doubt about it, right? But on the right-hand side is more important. So let's go ahead and solve for x. Let's bring the bxz here and put the b on the right hand side, and then go ahead and factor out x. A minus bz equals b minus az, and then divide both sides by a minus bz to find x. Remember, our goal was to solve for x in terms of z. Now, one thing that I would like you to do here is to negate both the numerator and the denominator, because you want to have the main variable first, kind of like you write it in standard form, sort of. Like how we write mx plus b for linear functions, but we don't want to write it as b plus mx. Even though it is correct, it doesn't look standard. So let's go ahead and write it as az minus b divided by bz minus a. You can obtain this by multiplying both the top and the bottom by -1, which is equivalent to multiplying by 1. Great. So x is equal to that. Now what I can do is I can replace this x with that. So I know that x equals something, so I can go ahead and replace x with that. So that's going to give me the following. F of, now remember, this whole thing was called z, right? So we called this z. Therefore, it's just going to be f of z on the left-hand side, which is cool. I don't have to worry about it. I mean, if you want to verify that it's going to be z, you can go ahead and plug it in, but that's not needed. So now x replaced with az minus b divided by bz minus a. Of course, we have x squared, so we have to square that. And then what else do we have? Minus 3x plus 1. Minus 3 times x, which is this, plus 1. Awesome. So that gives us pretty much f of z. And you can go ahead and simplify this, like square it, make a common denominator, so on and so forth. But that's not needed. That's kind of unnecessary. Let's go ahead and find out f of 1 and f of negative 1 from here, because we have an expression for f of z. Now at this point, if you replace z with x, you're going to get f of x, but that doesn't matter again, and that could be confusing for some people, even though it shouldn't be, because we already called x something, but that's not the same x. These are just dummy variables. You use them and throw them away, and then you use them again. And every time you use it, it has a different value. It may have a different value. Okay, great. Anyways, let's just go ahead and find f of 1. So replace z with 1. That's going to give you f of 1 equals a minus b divided by b minus a, quantity squared minus 3 times a minus b divided by b minus a plus 1. Now notice that a minus b divided by b minus a is -1 because those are opposites. So it's going to give you -1 squared, which is 1. This is going to give you -1. So it's going to be plus 3 plus 1. So f of 1 is going to equal 5. Awesome. Let's go ahead and find f of -1 by replacing z with -1. If you replace z with -1 in this expression, you get a times -1. So it's going to be negative a minus b divided by, at the bottom, you're going to get negative b minus a squared minus 3 times the same thing, pretty much, negative b minus a plus 1. Now notice that this time you're not getting a negative 1, but you're getting a positive 1 because this is positive 1. Obviously, if a plus b is 0, this is not going to work, so you don't want that to happen, so on and so forth. But anyways, this is going to be negative 1, positive 1. So what am I talking about? Positive 1 squared is 1, 1 minus 3 plus 1. And from here, f of negative 1 is going to be negative 1. So we got the two values. We're supposed to add them. F of 1 plus f of negative 1 is just going to be 4 in this case. And that brings us to the end of the first method. Not to the end of the video yet, because we're going to do the second method now. Let's go ahead and talk about the second method. Now, these two methods are commonly used with functions, and obviously the second method is shorter. So we have this equality, and we're supposed to find f of 1. So instead of trying to solve for f of something like a single variable, why don't we just try to set what is inside the parentheses equal to 1? So we can directly do this. So here's how it works. I want f of 1, so let's go ahead and set this equal to 1 and find the x value that satisfies it. So ax minus b divided by bx minus a, I want this to equal 1. From here, cross multiplying gives us ax minus b equals bx minus a. Now our goal is to solve for x so that we can replace x with something on the right hand side. So let's put the ax bx together, and then on the right hand side we're going to have b minus a, and then if you take out an x here, x times a minus b equals b minus a. Now b minus a you can write as negative 1 times a minus b, so you can kind of write it like this, and then provided that a does not equal b, of course, you can divide both sides by a minus b and get the value of x from here. So x is going to be negative 1. For the parentheses, inside the parentheses to be positive 1, you need to use negative 1. So in other words, this means f of 1 equals negative 1 squared minus 3 times negative 1 plus 1. That is equal to 1 plus 3 plus 1, which is 5. So f of 1 is going to be 5, and let's go ahead and find f of negative 1 the same way. So we have this equation again, and we're trying to find f of negative 1. To set this equal to negative 1 means this whole thing is equal to negative 1. Let's set up an equation for that. Ax minus b divided by bx minus a is equal to negative 1. Cross multiply ax minus b is equal to negative bx plus a. And then from here we get ax plus bx equals a plus b. And clearly from here x is going to be positive 1 as long as a plus b does not equal 0. So if x is equal to 1, I can go ahead and substitute that here and here to find f of negative 1. And f of negative 1 is going to be 1 squared minus 3 times 1 plus 1. And that is equal to negative 1 as before. And we got the two values. F of negative 1 is negative 1 and f of 1 is 5. Therefore, their sum is going to be 4 as before. So f of 1 plus f of negative 1 is going to be 5 plus negative 1, and that is equal to 4. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.